So I'm just using the factor theorem for that special polynomial, as you can see, okay? Namely, okay, we have to see, does this equation have A as a solution? If it does, then x minus A is a factor. I know this step here is probably more work than necessary. I mean, hopefully you can see that x is not a factor of the denominator. Mostly because there's a non-zero constant term. So it's not like the numerator where every term had an x in it. Okay. However, I'm just demonstrating the process, so to say, with x, because x is the same as x minus 0. With x plus 2, remember, that's the same as x minus a negative. It has to be x minus. So that's why I'm using negative 2. But if you plug that in, you end up getting 0. You end up getting 0. And so what does that tell us? Well, by that factor theorem, again, it's up here for this polynomial. We get that x minus negative 2, so x plus 2 must be a factor of this. So let me say it again. Since negative 2 is a solution of this equation, that tells you, in other words, if negative 2, you replace x by negative 2, you get 0. That tells us x plus 2, x minus negative 2, that is a factor of the polynomial. Okay, so can we use that? Well, yeah, because if we divide, that's what I'm showing here. What we can do is get the other factor. What's nice about this is this just requires synthetic division. And that's what I'm doing. Right, for synthetic division, you want to make sure you have x minus something. So you have x minus negative 2. So the negative 2 I put over here. The coefficients of the dividend, right? X plus 2 is the divisor. This polynomial is the dividend. We get 3. We get 2. We get negative 8. Those are the coefficients, right? And the constant term. We bring this 3, we bring it down, right? We multiply, put the result here, and add. So we have negative 2 times 3 is negative 6. Put it over here. We add, we get negative 4. So now we repeat. Negative 2 times negative 4 is 8. Negative 8 and 8 is 0. This is the remainder usually. Okay, but it's 0, so there's no remainder. These are the coefficients of the quotient, and it's 1 degree less than the dividend. So we get 3x minus 4 as our dividend, as our quotient, excuse me. And the remainder is 0. So this is telling us that this here is equal to 3x minus 4, or equivalently this, as you can see. So we factored this. So if we replace that in the denominator from here, right? We put it in the denominator. There will be cancellation, namely x plus 2 you can cancel. That's what I did. Those cancel. Let me draw it in. Cancel, cancel. And we get x times x minus 1 over 3x minus 4. And that's what we get. Are there any questions about this or the previous example? Are there any questions? You know what? Let me do this instead. Someone said no. Oh, wait. Oh, oh great. Oh, man. What questions do you have? All right. Hope I didn't go too fast. Let's do it. Let's see. I have there's one yeah. Let's do this one. Then I'll let everyone try some on their own. Let's do this one, okay? So basically, again, the previous example, we had division. And for simplifying, you could just factor and cancel the common factors. For the previous one, actually, all we did was simplify. So we factored top and bottom. Well, essentially what you would do is factor top and bottom and cancel common factors. You could have factored the denominator, but I was just trying to show you another way. It's good to have more than one method in your repertoire, so to say, or at your disposal. What if for some reason you forgot the AC method, Well, we have another way to do it. You can use synthetic division and the factor theorem. But if you factored the denominator, that'd be fine also. So for this one, same idea. We're dividing, right? Since we're dividing, as you can see, what you would do is you would take the reciprocal of the second, and then you're just going to multiply. Now, what I did here was I kind of combined two steps. I factored top and bottom of each one. Then I multiplied before I actually multiplied them. I know it looks like it's out of order, but really in the long run, it doesn't matter that much. Basically here, you can just factor top and bottom, right? And then we multiply. Or you can multiply first, then factor. And when you do so, this is what we get. Like so. And as you can see, by doing that, we can cancel it. And the only real thing you can cancel, as you can see, is x plus 4. So those cancel, and they're gone. And we get this. So I know this one hopefully is not too confusing. I mean, I probably should have stuck with the order of it. But really, in the long run, doesn't really matter that much because we're going to simplify anyway. But to divide, again, you take the reciprocal and you multiply. What I did was, I probably could have done this after multiplying. Actually multiplying, that is. But I just factored the numerator and denominators. Although x minus 2 you can't factor. Okay? Then you cancel common factors. So we multiply, then we cancel common factors. Oh boy. Okay. All right, so these two I want everyone to actually try. Before we get to that, are there any questions on this? Okay. So for this one, I want everyone just to try, not to hand in, okay? But I do want everyone to take a shot at it, okay? I'll give you guys 5 minutes.